Hi, so today I wanted to talk a little bit about Tracee, which is our eBPF tool for tracing events from containers or from other processes running on the host. And we've just recently converted that code from Python into Go. And I'm joined today by Itai Shakuri from our open source team. And he has just been working on doing that conversion. Hi, Itai.
Hey, everyone.
So first of all, let's talk a little bit about why we wanted to convert that code from Python into Go. What was the thinking behind that change?
Yeah, sure. So I think when Tracee started as an internal part of one of our products, choosing Python was a no-brainer back then because we looked for the quickest way to achieve the goal that we had. But after we decided to open source Tracee and make it an open source product and build a community around it, then we had to rethink the language choice, and we decided to move to Go. I'm trying to think about the reasons. I think there are a few reasons there that contributed to the decision. I'd actually like to start from the non-technical reason, which is the community. We work and operate and live in the cloud native ecosystem, which is very Go influenced, and a lot of the other products are based in Go. A lot of the people that work in this community use Go on a daily basis. If we want to invite people to try Tracee, to contribute back to Tracee, probably Go would be the easiest choice for them. Or if they wanted to integrate with any of the other cloud native products out there. So yeah, this is one of the reasons that we chose Go. Yeah, another reason probably is about security. So it is debatable, but I think that Python, so first of all, it's an interpreted language. There's this debate, which I will not go into. Also, there's a lot of, you need to choose the version of Python that you want to support and distribute. There's a lot of different distributions of Python that you may want to recommend or integrate with. And with Go, it's a lot simpler, right? You just build a binary, you ship it, works. So in terms of security, and Tracee is a tracer, but it is security-oriented tracer, so it meant something for us.
I think not having to ship a whole load of Python dependencies does make it a lot easier to distribute. I mean, we could be building a container and running Tracee from a container, but just being able to distribute a single binary has a lot of advantages, both in terms of just shipping it and also knowing that we're not shipping some dependencies that potentially have vulnerabilities either today or that might get discovered in the future. And then I guess the last reason, but one that's had a lot of impact, is really about performance, right?
Yeah, we had a hunch in the beginning that the performance will be better. I think we even underestimated how better it will be. And from the initial test that we did of the Go version of Tracee and the Python version of Tracee, the Go version performs a lot better, both in terms of perceived speed to the user, but also in terms of not losing as many events. So when we talk about eBPF programs that trace the system, or actually any other event collecting system, there is this notion of lost events, which means that we have a buffer that is being used to communicate the events from the kernel to the user space, and it has a finite size. And if it fills up, we are going to lose events. And we saw that with the Go version, we are losing a lot less events, which means that the Go version just manages to process those events faster. And this was a very big win for us in this migration to Go.
Right, so let's just drilling down into that question of the buffer. So we have a finite size buffer. Maybe it's configurable, but it's still finite. It's a circular buffer. And we're writing events in, and if they don't get read out before we fill up that buffer, we're going to start overwriting some of the older events, and they are forever lost. So
yeah.
the Go code in user space is reading those events back out again, and it's better able to read those. It's operating more quickly, so it's able to keep up with the speed that those events are being written better, right?
Exactly, yeah.
Yeah, great. So in order to write eBPF code using Go, you had to do some work with Go BPF, which is, I think it's mostly maintained by some folks from Kinfolk, right?
Yeah, so I saw in the GitHub repository. I gotta give it to them. The migration was pretty smooth. Changing the code to use this library instead of this library, it was pretty straightforward. We did have a couple of setbacks where we had missing features that we were using in the Python version that we didn't find in the Go version, in Go BPF. One of them was the ability to configure the size of this buffer that we just discussed. So in Go BPF, it used to be hard-coded in the code, and this was since changed. And the other one was the ability to handle lost events. We also discussed lost events. So there's nothing really we can do about lost events, right? But we just want to know about it. We want to report to the user just so they know we witnessed this many lost events. This was also missing, and we were able to contribute this back to upstream Go BPF and also use this functionality in Tracee Go.
Fantastic. So now we have Tracee written in Go, performing better than the previous version, and allowing all kinds of interesting events to be traced from your containers or from the underlying system, actually from any process. Great. Well, thanks very much for talking us through that. And if you're watching this video and you want to try Tracee, there's a link in the description where you'll find Tracee on GitHub, and we would love your feedback.